Welcome back, chat. Today we cook with systems of equations and inequalities. Okay, so chapter 7, we are looking at systems of equations and inequalities. How many of you remember seeing this stuff before? Okay, quick check. Can those of you that just raised your hand, can you tell me what it is that we're looking for? Like if I say here's a solution to a system of equations, what is it that I'm asking you to find? An ordered pair. Any ordered pair? Yeah, so where two or more equations happen to intersect. And we can be a lot more formal with this, and we will be a bit more formal with it. But to start off, I want us to look today at 7.1, and we are looking at substitution. So 7.1 is our focus. That's this section. Substitution. I'm going to sneak this in as a vocab right off the bat. Substitution. Okay, and we'll define this. I'll do it right underneath just so it's consistent with the way that we typically write stuff. But I do want to speak to a few things first, just to kind of get us up to speed with things. So I'm going to leave a bit of blank space just for a definition right here, and we're just going to add in a quick recall. Okay. A system of two or more equations has a solution or has solutions, which I'm going to just put solution with an S in parentheses. Okay, a system of two or more equations has solution or solutions, and it depends on the particular situation that we're looking at. At the points that make both or that make all equations in the system true. Okay. That's it. When we solve a system of equations, we're just looking for any ordered pairs or triples or four tuples, whatever you want to call them, however many coordinates there are, it just depends on the dimensions that we're looking at. We just want every equation to be true. Now, when you guys have used systems of equations historically, an easy way to think about this is the intersection on a graph. And I'm going to say the intersection with, again, an S in parentheses, of graphs. Okay, that is all that we're looking at. We want to find when do two or more equations or graphs happen to intersect, which their intersections will be points that are on both of them that make it true. As we look at this, substitution, super chill. Solve one variable, and I'm going to use var as my shorthand. In terms, of the other. And substitute, which I'm going to use subst, in. All right. That is all of the conceptual stuff that you guys would have seen with substitution in Algebra 1 and Algebra 2. You did a little bit, I assume, of substitution and systems of equations in geometry, but that's been a couple years now. Okay, just to check, if we did a single problem right now, how many of you think you could solve an easy substitution system? So I'm getting some nods and some, I don't know how to describe that face, but whatever it is. Let's dig in here real quick. We're going to do an example together, and then we'll base how detailed our directions need to be on how this goes for everybody. So for an example, oh, you need me to scroll back up, Huggins?
Yeah.
Okay.
I just left it blank like you did.
No, you're good. Solve one variable in terms of the other and substitute in. Okay. So we're going to be real specific, and we're going to solve by substitution. Now, what I didn't give you this year, just so you guys are aware, on my notes I have like, hey, here's the 5 steps that you do for substitution. But before I just give you those 5, I want to see it at work and just see if we really need to have them all jotted down. Okay, so we're going to start with a fairly easy one. And on A, let's consider the following system of equations. We have 2 linear equations given to us in standard form. And we'll say that it is x minus y, here's one equation, equals 3. And furthermore, we also get 3x minus 4y equals 7. Now, notationally, I like to write them like this. When I write on Microsoft Word and I'm like writing your tests and stuff, the only way I can do it is by including these brackets. So you may see those from time to time to indicate, look at this system of 2 equations. Okay. While we look at this, I'm going to annotate like crazy. Remember, you don't have to write down everything that I do. You can change the language, or you can omit or get rid of stuff that I write down. Entirely your call. As soon as I write this, though, thumbs up, thumbs down. Does it look more familiar than when we were just speaking about it? Okay, so as I'm looking at this one, this is, I would say, like an Algebra 1 style of substitution problem. Which of these equations can I really easily solve for either variable? I think it's the top one. Now, the cool thing is it's uglier, but could I also solve the bottom one for x or for y? So we get so many choices. My first step, and I'm just going to put them right here, I suppose. Okay, which equation are we solving and for which variable? There's not a right answer. There's an easiest answer, but there's not a right one. What do you think, Makisha? Do you want to solve the top or the bottom equation first? Okay, and which variable would you like me to solve it for? I need to say x equals something or y equals something. Say it again. Okay, solve top equation for, and I'm going to be real specific with language here. We're going to solve it for x in terms of which variable is going to be in our x equals expression. So Abigail is confidently whispering y. When I say solve first equation for x in terms of y, all that means is that x equals something with a y. That's all that it means. Okay, I think we can do this. So I'm going to switch to, I don't know, green feels kind of systems of equation-y. Equation 1 becomes x equals 3 plus y. And if you need me to, I'll go ahead and just add this in here. We had x minus y equals 3 becomes x equals 3 plus y. Everybody good with that? We have solved one in. Now, when we shift our focus to the second equation in this system right here, is there an x in it? There is, right? And that's an issue because if I want to solve for a whole system, I need actual numbers for x and y. If I have an equation like this, either of these, this equation has 2 unknowns and it's only one equation. Can't do it. Luckily, we get this other guy given to us to hook it up. So here we go. Here's our substitute part. Substitute x equals 3 plus y. I hate that y. Into the other equation. And I'm going to leave, I have like 1/2 line here. When I do that though, and I can write it down just to see what it looks like, that means my second equation becomes what? And I'm going to leave blank space right here because I need like 3 more words. But let's go back to green and just see what that looks like. When we substitute in, my second equation was 3 times x, right? But what was x, did we just say? 3 plus y. So 3 times 3 plus y, that's 3x minus 4y still all equal to 7. Now, that's the substitute x equals into the other equation. And, gosh, I now have a new equation in front of me that has how many variables in it? 1. Can you solve one equation for one variable? So we're just going to say substitute this in and solve for y. I'll switch back to black. Solve for y. Okay, I'm going to give you guys like 60 seconds. I'm going to use this fancy ... to say, look at the algebra that happens here. And I want you guys to work out and get me a numerical value for y. I'll give you like 60 seconds, starting right meow. Kalisha, if you're watching this, go ahead and pause it. When you resume, you'll see the value for y in 3, 2, 1. Everybody okay with y equals 2? Now, this isn't our answer, but I'm going to put a star next to this because I'm going to use it. All right.
Why isn't it negative?
Because if we look at this, do you agree this becomes 9
Yeah.
plus 3y minus 4y
Yeah.
equals 7?
Yeah.
Okay, negative y equals, and I'm going to subtract 9 from each side, negative 2.
Yeah.
I don't want negative y, though. If I multiply this side by negative 1 and this side by negative 1.
So you just don't want a negative?
Nope, I want it to be exactly y. Not for negative y, just for 1 y, positive 1 y. Good follow-up. Okay. Anybody have a suggestion for what we do now? Because I have half of my answer. Now I need a value for what? For x. Now, here's, like, I love these, but people get goofed up on them. We now use this result, use y equals 2, and I'm going to be real specific with language. I don't normally use this, but your book presents it. I'm going to refer to this as back substitute. Into the first equation. And I'm going to just say the other equation, because maybe we chose the second one. Now, before, I don't have a nice way to write this down, but once we state this, I want, if you guys give me your eyes up here for a second, once you have it written. You have choices. This is equivalent to this. These are different versions of that top equation, right? I don't care which one you plug into. We're going to get the same answer. 99% of the time, so long as the work is clear, I'm going to plug into that second one because it's already written for x equals. So we use this, we back substitute into the other equation and solve for which variable now? Good. For x. Cool. Now, looking at this, I'm going to keep my color. I have x equals 3 plus y, but we just decided that y was 2. Now I get 3 plus 2. What is x? Okay, before I do anything, I'm going to put that star there because I'm going to use it. Okay, I am kind of hardcore about notation stuff. On and off, like I should probably be more consistent, but this is one of them where I'm going to be really hardcore with the notation. When we look at this, this is an ordered pair right now. This is a spot on a graph, which means it should have parentheses. Before I commit to it, we said right at the beginning that this system, its solution makes which equation true? Both of them. And in fact, it has to make both of them. This last step is something that I always do, typically mentally, but you can write it down if you need to. When we do this, check that both equations, or all rather, in case there's more, all equations are true, then write solution as ordered pair. And remember, SOL apostrophe N is my shorthand for solution. Okay. If you are a mental math pro, this is easy. If you're not, it's going to take a little bit more work, but we should check our solutions every time, especially with nice numbers, always really, to verify. And we can mostly do this just in our head. I know that x is allegedly 5 and y is 2, right? That's what we found. 5 minus 2 is 3. Is that true? I'm good. Can I just stop there? Am I guaranteed the other one's true now? No, but let's check. 3 times 5, that's 15, minus 8 is 7. Is that true? Good. So it means then our solution should be a single ordered pair represented by the 0.52. I'm going to use these curly brackets because we could have more than one, and we're really looking for an entire set or a collection of a bunch of different ordered pairs. There's only one this time. Check it out. It is the single ordered pair consisting of 5, 2. Okay. Well, how's it feel? Everybody remember doing this. Do you need to see me graph this to show you that they intersect at the 0.52, or do you believe me? All right. Should we do a little bit harder one? Good. Love the enthusiasm. With these, just your guidance. If you want to jot these down in... Weird. If you want to jot these down, I'm just going to put it on the video, but we're not going to take time to write it down right now. This is everything that we just did. I'm just going to screenshot this and we'll throw it onto the video. This is the method of substitution drawn out from what we just did, but just standalone. If you want this, it is on the video for you. Cool. All right. Let's try a harder one. And by let's, I mean I want you to try a harder one, and then if and when we need, we'll come back together. So let's see. I don't know that I have space. We'll do it right here. All right. This one is your guys' turn. Now, this example A, that was a linear system of equations, which is, I would imagine, the bulk of what you did last year in Algebra 2. We're going to step it up, and I just want to see how it goes for everybody. Here we go. I have a system of 2 equations again. Our first equation is represented by the following. We get 3x squared minus 2x plus y. And I claim that that is equal to 0. But you also get y minus x equal to negative 2. All right, I'm going to show you just my notation stuff, and I kind of hate that I lined those up, so I'm going to change that. Y minus x equals negative 2. Okay. Right off the bat, let's just all agree, just to make sure we get the same thing. Are we going to solve the top equation or the bottom equation first? Good choice. Could we do the top one if we wanted? You could. I don't want to. I kind of doubt you want to. Let's all solve the bottom one. For which variable? You're going to solve it for y? Okay, I'm going to work the problem. I'm going to solve the bottom one for x, and then we'll meet back up. Cool. Talk it out with your neighbors. You will see a walkthrough solution in 3, 2, you know what to do. I did this problem solving for y, and we did similar factoring. Mine's a little bit uglier, but we're going to get the same answers. Once I get these values of y, and I have them starred, and I would encourage you to do it just like this, I like to do the following. I add a little scratch work, and I'll switch colors here, because I want to make sure that whatever values I get for x correspond appropriately. What I mean by that is I know x is going to be equal to, and it looks like I would have to use this equation. I can use y minus x equals this, or I would use, yeah, I'm good with this. We already have it, right? Okay, so check it out. I'm going to plug in the y values that I found. The first one is negative 8/3. So I know that that would be x equals negative 8/3 plus 2. Now that's 6/3, right? So corresponding with this, I believe I get negative 2/3. Is that correct? And you guys got the same. But where I would like to stress, like keeping stuff straight, if I wrote negative 8/3 first, the value of x that I got when plugging that in is what I should write first. I'm going to be really specific with the order so that I see these two match every time when I'm writing it down. Because if I get 3 pairs or 3 points or 4 points or 5 points and I have to try to keep straight which one goes with which, it's an easy place to get goofed up. This is my workaround for that. Alternatively, I also got -1, so I'll just try that one. X equals -1 plus 2, and I think I get -1. And here it is. Just kidding, it's a positive one, but other than that, I like it. And I now have these x's and these y's corresponding as well. Before I write my answer, what should I do? I should check it. Realistically, who here is going to check to verify that 8/3 and 2/3 go into that nicely? I agree with that. Just for the record, nobody raised their hand. If you had to, like on a test, you could. Is there an easy way you could evaluate this? If you were to go into your calculator and solve for y and call this y1, you could do y1 of, and you could solve this one for y and get y2, and you could use that trick that we use with the calculators to help you verify this. Okay. I checked them. They both work. How should I write my answer so I don't burn you on points? How many? So it's 2 ordered pairs, and I'm going to write them as a set. The first ordered pair is -2/3 and -8/3. Love it. The second ordered pair looks like it's the 1, -1. And look at that. We have our system of equations with 2 solutions. We have a nonlinear system all of a sudden. I don't think you guys did any of these last year in Algebra 2. I don't recall. It's been a while since I've taught Algebra 2. Significantly more challenging problem with the algebra involved. Conceptually, though, is it any different? Not even a little bit. Do all systems have solutions, do you think? Okay, so this is totally on the spot. I'm going to introduce a new example, and it's going to be really informal. I want you to sketch a system with, and let's check a few. On A, I want you to do 1 solution. On B, I want you to do no solution. And on C, I want you to do infinitely many solutions. Now, I'll sketch one example of this right off the bat. Here's my ordered, or my coordinate plane, and these are going to be real rough sketches. I'm going to copy and just do that. Okay. There are so many answers with this. Check it out. Here is a graph that looks like it has horizontal asymptotes. That's F. And here's G. You can draw any picture that you want as long as you see how many intersections on the graph. 1. Okay, I want you to do the same thing with 2, and I want you to do the same thing with infinitely many. There are so many different variations of the answers and graphs that you could have. I'm going to come around and look over your shoulders, and if there's any that are like super interesting to discuss, I'll steal your page and I'll come throw it up here. Cool, sketch them out. Okay, I saw several examples here. I didn't come look at all your pages. If I do this perfectly, that's the natural way that you look at it. This is how these present themselves in geometry. When you're looking at distance between parallel lines, that's a system of equations problem. How many of you guys went with this graph? Anybody have a non-linear system with no solutions? Love it. Okay, Riley went with this. There's a parabola and a line. Awesome. They also never intersect. Could you do a parabola and a parabola? I'm not going to draw them all. There's a lot of them. Okay, the infinitely many solutions is an interesting question for a few different reasons. Most people do this. There's my first line. You got to pay attention real carefully, okay? There's my second. What did I do? They're the same line, just like x plus y equals 4 and 2x plus 2y equals 8. They're the same equivalent equation, infinitely many. My mind goes to more interesting stuff. You guys have seen stuff that looks like this before, and we'll see it again. This is a trig function, and it just keeps waving, right? How many times will this line touch it? Infinitely many. There's more interesting answers than just this. You could conceivably come up with an example for any number of solutions that you'd ever want. I can think of a 3 or 4 or 5, and eventually I think that I'm just going to start following a pattern, and I could go from 0 to infinitely many. Cool. All right. Do we want to learn how to type these into a calculator?
Yes.
Okay. Deal. But we're going to do it in the form of a word problem. Sweet. Now, I'm going to be honest. Graphical approaches to stuff don't love. And they're really efficient if you are good at the calculator, but this is not calculator class. This is Precalc, right? We're developing all these techniques for math. A lot of the times, problems that we see are going to wind up being calculator problems, especially if they're applicational. I tend to focus more on the pure mathematical standpoint or point of view, but it's nice to see the applications of stuff. So let's look at some applications. Apply. Now, there are tons and tons and tons of situations that this could be applied to. For our first one, I'm going to be kind of wordy, so I'm going to pause it and I'm actually just going to type it. All right. So Holloway Portraits R Us. We started it for $6,000. I sell a portrait for $35.20, and it cost me $23.20 to make. I want to know how many of these we have to sell to break even. Right off the bat, what does break even mean? Zero what? So I haven't lost any money, I haven't made any money, right? I just covered my initial investment. So, looking at this, okay, we need to figure this out. The number one issue that I've seen with word problem stuff is people just never know where to start. There's no equations given here. Our job is going to be to write them and like craft them and use them. So, we need to pick some variables right off the bat. It's pretty common that X and Y are used, but we can use whatever you want. What do you guys think? Cool. So, check it out. You guys probably most comfortable using X and Y, I assume. I might have missed something funny, but that's all right. Well, what's X going to represent? It's a number of something. Say that again? The number of portraits? Yeah, I'm fine with that. Number of portraits. Okay? And then a couple different ways that we can do this. Number of portraits, then let's let, I'm trying to work this out, C of X equal the cost to produce. So we're going to write an equation for this using X. What else do we need? And we're going to learn some business terminology. Cost. We have profit, which is like the benefit, the plus money that I make. What do you call the money that you bring in before you start profiting on it? So gross sales are a good idea. You're close. Starts with a revenue. So I'm going to use C of X as one function. This is just Y, but I want to be more specific contextually. C of X is the cost to produce. And to produce, I suppose, X portraits. And I'm going to use R of X equals a revenue from X portraits. Now, committing and deciding your variables right off the bat will make these problems 1,000 times easier. Every word problem that you ever deal with systems, they look ugly because it's easy to kind of gloss over this and just think everything's going to be fine. Help me write these equations. The cost that I put into the business. I'm going to say plus question mark because maybe there's something else we have to add. How much did it cost me to start my business? So $6,000, and then for every portrait, it cost me how much? So if I want to know how much money have I put in to make any number of portraits, do you guys agree it's $23.20 for every portrait for all X of them? There's that much that I have to pay for that many. Plus, how much initial? $6,000. Do I have to pay that $6,000 over and over and over? Or is it just a one-time deal? So notice there's no X connected to it. Here's one of them. Okay, how about the revenue function? How much money does it bring in? 35.2 times X portraits, right? There's nothing else in there. So 35.2 X. Now, if you wanted, and I would advise against it, but could we call this, don't cross yours out, could we just call these both Y and they're just two different functions of Y? I've just added context. Okay, with that in mind, I'm trying to find out when they break even, right? I'm going to just state the following, and you should include this. Break even when the cost that I've put into the business is exactly equal to the revenue. Anytime cost equals revenue is when we break even. All right. Could you solve this by hand? I think so. They're ugly numbers, but you could do it, right? It's just subtraction and ugly division. Do me a favor, grab a calculator. That one's still dead. Does that say HK5 on the back? That's weird. No, not one in there. I have new calculators coming, but they're not these fancy ones. Oh, here's mine. You can borrow mine. I'm going to talk about that next to you. Okay, so we're going to see. Hopefully she doesn't wear headphones. Tell her to turn it down.
She always wears headphones.
Yeah, that's full volume.
Goodbye, collision eardrums. All right, do me a favor. On your calculator, go into Y1. Y equals. And you're not going to change anything. It's still going to say Y1. I want you to plug this in. 23.2x plus 6,000. Once you have that typed in, we have it, hit enter, go down to Y2, and either erase or write the second equation. 35.20x. Vern, what are you, like, speed clicking for?
Oh, this is
Okay. Now, I'm going to talk to the little lad next to you for a second. Hit enter, and then go back to your home screen. If you go to graph, the very top right button, all of our scales are going to be, some of them are going to be wonky. Okay, like yours is especially wonky. Can you guys see the graphs? So, instead of having to try to figure this out, I want you to hit the zoom button. Sorry to talk so loud. I always hit 1 up. Oh, just kidding, that's the other calculator. Go down to 0, so scroll down instead, sorry. 7890. And it should say zoom fit. Hit zoom fit or just hit zoom in the 0 button to get to that, and you should be able to see both graphs. Okay, some of them did, some of them didn't. Bummer.
What's zoom fit?
Zoom fit is just supposed to fit the data for you. Unfortunately, I can't see where they intersect. Huh. I liked what you did, Fern. Because when I see zoom fit, I can't see them intersect, because they just do that, right? Okay. What did you do?
I went back to white.
You what?
I went back to white just to see if I did anything wrong.
Okay, so here is my suggestion. Looking at this, the zoom button, if you hit it again, do you see an option? Everybody should. Do you see zoom out? You can either scroll down or you can just hit the number 3. If we zoom out once, can you see them intersecting yet? Nope. So zoom 3 again. intersecting yet? Almost. Go one more for me. And I don't know if this is easier or harder than just picking the scale itself, but
I didn't really can't see it.
okay, that's all right. That is fine. If you can't see them, it means that they're too small, right? But I guarantee they intersect. I'm gonna talk to the lad next to you. Okay, once we're here, I want you to hit second trace on the top right. It says calc in blue written above it. Okay, option 5 says the intersect. You can either scroll down or you just hit the 5 button. Before you hit another button after that, on the bottom left, you see it says first curve. First curve. And then up top it says y1 equals whatever. Okay, so I'm going to catch you here. Yep, first curve and y1, right? Hit. Once you see first curve and y1, hit enter. Okay. If you hit enter, go ahead. It now says second curve. And it should read the other equation, yeah? Hit enter again. Now your calculator, all it's going to do is can approximate, or as it says, yes. Hit enter. And for this problem, what did you get for x?
500.
Exactly 500?
Yep.
Cool. Okay.
Did you guys get that? She got error too.
Error. All right, so we're going to check it out. So it says no sign change. And I'll show you. Nothing. Okay, so if we look at the graph, I see the first equation going.
Yeah, isn't this the intersect of the x?
Nope, it's going to be the intersect, so we'll get there. So I'm going to just try again to see. So I see first curve with y1. Nope, hit the wrong button. Here we go. First curve, enter. Second curve, enter. Guess, and it might say no sign change still. Okay, if this happens, what this means is that my scale didn't see it. Like it just didn't see the intersection on the graph. I'm going to go one step further. Zoom out one more time. It's going yard here, but I have a feeling this is going to work. Calc, intersect. Y1, yep. Y2, yep. We get a different number.
I got it.
32, 23.2. Hey, look at that. 35.2. I might have said it wrong. We're going to let it guess again here in a second. I suggest that someday we end everything with an upward inflection.
Okay. There you go.
Cool. Ooh. Okay, now looking at this. I get the ordered pair 500, comma, 17,600. In this question, sorry if I just said that back to the wrong person. I'll write down that y value as well. 17.6, right? Okay. I want to be able to write this answer with the appropriate context. Which one's our answer? 500 or 17.6? Okay, so help me phrase this, and we're going to write a sentence here. We break even after selling how many? 500 portraits. Okay, I could have asked how much how much revenue do you need to break even? We could have answered that, and I'm just going to put this in parentheses because it wasn't the question that we asked, but it's just a different way to express it. We need to sell $17,600 worth of pictures or portraits to break even. Now the good news is that demand is super duper high for Holloway portraits these days, so it'll go pretty quick. Okay, one more that I want us to check out. You don't even have to write it down, but I want you to do it on your calculator. I'm not a huge fan of the calculator stuff, but I'll show you a couple things. Before we leave this behind, the applicational side of it, what's the most important piece of advice that I told you? Every problem like this, you have to do what first? Pick your variables. Like if it's x and y, fine. I like to use the equations and functions with names that make sense. Always do that first. Cool. All right. One more for you guys. This is a calculator problem. You don't have to write it down. I'm going to erase it here in just a second. Example B. I want you to solve for me when it happens that the following system has the solution. For most of them, just so you know, Zoom 0 is like my standard go-to. Zoom Fit works. Zoom 6 is Zoom Standard, which is a 10 by 10. Zoom Fit will make your data nice. Zoom 0. Anyway, one equation is the natural log of x. And the second equation is 1 minus x. Now, very few times, so there's probably more than I want to mention. You guys solve that system right now. Using your calculators, if that wasn't specific. And you'll see here in a second why I'm making you use your calculators. It is not infinite, but that's a great thought. If you graph them, hit zoom. Did you zoom 0?
Yeah.
Okay, and that's what it gave you?
Yeah.
Interesting. So I can see the intersection. Try zoom 6. Those are like the two that I always default to. Zoom 0, zoom 6. Zoom 6 will probably give you a better picture in this particular situation. It'll probably look like that. Nar or Carm?
Yeah.
Oh, I love it. You didn't change your functions, man. Oh, you're good. So I'm just going to type in the right functions, and then I'm just going to go straight to zoom 0 because I want to see what it looks like. And then when I let it pick it. I yawn. I like. All right, couple things. If, depending on the view you took, it is very possible that you get something crazy for natural log that tries to do something like this, and you see another part of it. Calculators don't get asymptotes. They just don't understand it. I don't love graphing on these because of that. Furthermore, when you solve this system, I think you're going to get it pretty quickly. I think it's the order pair 1, 0. Okay, easy to do on the calculator, right? Now, we have the technology to do this, and you can honestly do it and get a pretty good idea from graphing. My issue with graphing, if I haven't vented and complained about it, you'll hear it again, I'm sure of it, is that on a graph, if I graph this by hand, how do I know if this is the point 1, 0 or if it's the point 1.010? Like, we couldn't tell the difference, right? That's my issue with graphs. They're good to estimate to get a good idea of what's happening. But I do want to see something else. Hypothetically, if I wanted to solve this one instead, and I didn't want to do it with a graph, what would we do? We're just playing the algebra game for a minute. So right off the bat, how do we get the x out of the argument? Can't divide. We have to undo a log. Exponentiate with base what? E seems like a good choice. Okay, I would do this, right? And I get e to the 1 minus x equals x. Huh. Well, hold on. If these exponents are subtracting, it means that maybe it was division? Right? Because a to the e to the x over e to the y becomes e to the x minus y, yeah? So maybe I look at this and I think, oh, well, this is just e over e to the x equals x. And I'm using some fancier stuff because I'm trying to solve it analytically. I don't like fractions, but I can multiply both sides. I wind up with e equals x times e to the x. And notice the issue here. Immediately, like guessing and checking, valid, it works. I can get it. However, we did this whole process to get the x out of the argument, right? And in doing so, we wound up with an x in the exponent. Which means to get this off, we have to do what again? So if I take the natural log of both sides again, natural log of e equals the natural log of x times e to the x. Is there anything we can do? So there's several things that we can do. What's the left side become? Equals, gosh, that's a product, right? How can you rewrite a logarithm whose argument is a product? So this becomes a natural log of x plus the natural log of e to the x. Okay, still good with it. What's this term become? So I get 1 equals ln x plus x. And then I look at this and I think, oh, well, I'm so close to solving, let me subtract x. But now, notice my x is stuck inside the argument, and welcome to circle land, we're never going to stop. It just keeps repeating, right? This is one of the few situations where we just don't have the ability yet to solve this. Can't do it. We need an alternative to solve these. Now, there are techniques that'll work. You don't have them in your toolkit yet. From time to time, and in fact, every time, your calculator is a super valuable tool. I prefer Desmos over your TI calculators, like always. But cool. I want you guys to do one problem for me tonight. And then here's what I'm going to do, just so you know. Today was super fast, super slow, felt okay. Where would you guys put it? Okay, I'll tell you, the lesson I just taught, traditionally 2 days. We covered it in 1 day because systems of equations are things that you've seen. Here's my recommendation. I'm going to give you one problem to do tonight. It's going to be out of your books, just so you know. Tomorrow, we'll hit a different way to solve systems of equations. Elimination is what we're going to look at tomorrow. And we'll probably do another applied problem or two for homework. And then Wednesday, I think it'd be fun if we just had a whole worksheet problems to say, hey, solve the system without me telling you whether it's elimination or substitution, and then you just have to choose and pick and practice. Cool. So for this evening, I want you to do the problem. It's a checkpoint problem on page 4. Lost my spot. Oh man, there's some cool problems we could do here. Okay, checkpoint problem on page 472. And I'll just take a picture of it here, and I'll throw it up on the board. Okay, on page 472, you get the following problem. This is going to be a 1-point homework. You know what? It's going to be a 5-point homework assignment. One problem is all, though. Either you get all 5 points or you get 0 of them. And I won't take late stuff. Cool. Do this problem tonight. I'm going to copy and paste it so I can put it on the...
What page?
Page 472, and I'll put all that information here in just a moment. Checkpoint. You can do this in your notes on its own sheet of paper, whatever you want. Cool. This is your homework due at the start of class tomorrow. Later, Raiders.